Beginners learning to program often face this dilemma. What they can master, they won't use. What they would use, they can't master. Why? Programming knowledge which can be applied has two grades. The first is the basic program logic, such as variable, branch, loop, etc., which are present in almost all programming languages. The related keywords and syntax are also quite similar. One with Excel experience can quickly master it. However, after learning this, you may find that you can only exercise your mind with mathematical problems, like solving the chicken and rabbit problem, or decomposing prime factors, which cannot address real-world issues. Unfortunately, many books and courses only go so far. To apply it practically, you need to learn the grade 2, which is the structured data and related operations. Most tasks in your daily work involve data in Excel spreadsheets, often referred to as structured data. Each row of the table is called a record, and each row has the same attributes, which is called fields. The whole table is a set of records. The operation of structured data refers to the operation of these tables, including filtering, grouping, join, and so on. Essentially, Excel provides corresponding operations or functions for these tasks. For example, grouping is roughly equivalent to pivot table in Excel. Join is equivalent to Excel's VLOOKUP. These are not difficult to learn. Once mastering the knowledge of structured data, you'll be able to manage daily work with ease and efficiency. Unfortunately, many programming courses either do not cover it comprehensively, or struggle to explain it clearly, as mainstream programming languages cannot handle structured data easily. If the programming languages aren't up to par, the train courses and textbook can't achieve much. After all, you can't make an omelet without eggs. For example, Excel's built-in VBA is readily available, has simple configuration, and comes from a reputable vendor. It seems promising. However, VBA is overly simplistic and struggles with handling structured data, often requiring extensive code to accomplish even basic tasks. What about Python, which is widely endorsed by training courses everywhere? Python indeed surpasses VBA with its robust support for structured data, but mastering Python can be challenging, as it is primarily used by highly skilled professionals. Python mainly uses something called data frame to process structured data. But this thing is not a set of records, nor is it a table that we usually understand. It is actually a matrix, with rows and columns named, making it look like a table. However, when using it for table processing, unexpected results often arise. For example, using an employee table to count the number of people in each department, the conventional approach is to group the table by department and then count each group. The result should be a two-column table consisting of department and number of people. But Python calculates it this way, as if it has applied the same counting action on each column. Because in Python, when a counting function is applied to a matrix, it will count each column. Unexpected. This correct result can only be obtained using the size function. However, this result is no longer a two-dimensional data frame, but a one-dimensional series, and it cannot continue to apply the methods of data frame. The grouping and aggregation result is also a structured data table with rows and columns. Why not stick with the data frame? Why invent something new? It's quite puzzling. There are similar phenomena. For example, the result of a simple grouping should be a set of sets. However, it actually appears as a data frame group by, which is different from the first two types and lacks sequential member retrieval. There are many analogous sets in Python, each with its own adaptation scenarios and operational rules, which can be perplexing. The transitions between them are remarkably smooth, and without careful attention, you might compute something unfamiliar. Therefore, programming basically relies on Googling, and you don't know why even you've got it working, and you'll have to Google again next time. In addition, Python processing of table data requires a third-party package, and the installation is a bit difficult. Python debugging is also a bit annoying, mainly still using the print method. What about the famous sequel? It is said to be dedicated to structured data. It's even less likely. Install the database, which will block 90% of beginners. Import data into database before calculation. Export data from database after calculation, both troublesome and professional. The language ability is not complete, and loop and judgment require the more professional stored procedures. The code for complex tasks is incomprehensible even to professionals. There really isn't an appropriate one among the mainstream programming languages. As a result, beginners are always asking what they should learn, yet always struggle to apply what they've learned. No amount of training classes can solve this problem, because training classes cannot create an appropriate programming language. This is fundamentally about not having eggs, rather than how to make an omelet. Well, esProc Desktop is here to address this issue. esProc Desktop offers the powerful SPL programming language, originally designed for structured data calculations. The structured data type in SPL is familiar to us as a table, which is essentially a set composed of rows of records. SPL has built in a wide range of structured data processing methods, making data manipulation very convenient. SPL facilitates intuitive coding, such as grouping and counting. After grouping, simply use count. SPL gives only one type of set, maintaining consistency in type both before and after grouping, and allowing continued calculations using the same functions. For instance, it remains a set after grouping, enabling retrieval of specific groups using the sequence numbers without creating anything new. SPL can efficiently tackle everyday tasks with concise code. For example, splitting one sheet into multiple sheets based on a specific column. SPL needs only 3 lines. Simplify it to 1 line is also okay. A more complex task, to find the longest consecutive rising days for each stock. SPL effortlessly solves it in a few lines, with the key code being just 1 line, without any need for loop statements. Python, on the other hand, is much more verbose and typically requires an explicit loop. Unlike traditional textual code, SPL code is composed within an Excel-like grid, making the programming process highly intuitive. This significantly lowers the learning curve for beginners. A cell name is a natural variable name that directly references calculation result. View the calculation result of each step in real time, making it especially suitable for step-by-step computations. Grid indentation also visually represents code scope, enhancing intuitive understanding. Debugging and troubleshooting code can sometimes consume a significant amount of time. SPL has comprehensive debugging capabilities, including setting breakpoints, single-stepping execution, and more. SPL provides a dedicated panel to display intermediate calculation results, eliminating the need for manual print statements. Installation of esProc Desktop is also simple. One-click installation, graphical guidance, no configuration. esProc Desktop also offers the SPL XLL plugin, enabling direct execution of SPL code within Excel, thereby addressing Excel's limitations. For example, finding the top 10 star products each month can be challenging using Excel's intersection feature. SPL's set operations are much more powerful, allowing for concise formulas that can directly produce the desired results. SPL is simple to learn and easy to use. Once mastered, enables efficient management of daily tasks. esProc Desktop is free to use and offers abundant resources such as books, courses, and Excel routines. Folks who want to learn programming, hurry up and download it to give it a try.